Welcome to this demonstration and introduction into MetaConfigurator, a JSON form generator and schema editor. In this tool, we will always have a data model, which we call schema, and we can either edit the data model itself in an assisted way, or we can enter data that follows the data model also in an assisted way. So the kind of data we work with would be JSON data in a JSON format or YAML format. But we can also import data from other formats, such as right now CSV, which would be a table. So without talking too much, let's just get into it and demonstrate the tool based on a real life example. So let's say we are from the field of biochemistry and we have a table, Excel table, of a set of experiments, every experiment having certain metal salt and a linker and some more information. So what we want to do is we want to apply some Python code and some tooling on our data. And also in the future machine learning and much more. However, currently our researchers, they all structure their data in Excel files in a different way, and so there's no unified tooling that can just run on it and work, but it's all a little messed up. So what we can do to solve this, to enable all this tooling, is to port our data into a JSON format and define a data model, a standardized data model that all researchers use. So all their data will follow the same structure, and hence it will be easy to apply tooling on it and even machine learning. So what we would do is we export this data into a CSV file. Save as experiments.csv. Now we go back to MetaConfigurator and we press import data, import CSV data, and we select experiments.csv. We just use all the default settings and import. Already now all data is in the JSON format. And we can also look at the individual items in this graphical view and also add new items following or having the same structure. What we did is actually we already inferred a schema, a data model, which we can take a look at in the schema editor. In this view, we can see the data model in a graphical way. We can also look into it. Now I'll click on this option in the text view. This is called the JSON schema document. It is a standard that is used all across the world. There are many papers on it. It is also industry standard. Most programming languages and much more they already support it. So if you follow this standard, you can just share your data model in this file and it will be usable and accepted across the world. But we don't have to work on the text form. We can if we already know how it works, but more easy is to just use this graphical view. Also, there will be another view that I'm going to show. So just quickly going back into our data view, what we would see is we have these properties such as the date, metal salt name, and so on, and they all have different types. For example, we have a temperature unit having type string. Now, this definition of type string in a data model would allow that any string can be used for the value. In reality, however, there's only a handful of temperature units that we want to work with. So what we can do is we can introduce it's called enumeration to limit the amount of options and only allow Kelvin, Fahrenheit, and Celsius. In the same manner, we can introduce some enumeration for mass unit. So let's go back to the schema editor and introduce this new enumerations. So we click on this button, add enum. We give it a name such as temperature unit. We enter the values such as degree Celsius, degree Fahrenheit, and Kelvin. And we connect it. In our temperature unit, we change our type into the new temperature unit type. Now let's navigate back to data editor, and already we will see that the type changed into enum, and now there is a set of choices we can make instead of any arbitrary string being allowed. So now let's do the same for our mass unit. Introducing kg, g, mg, and ug, mu, g, and also we can connect mass unit for the metal salt mass unit. Also linker have a mass unit, so let's also connect this one. Let's rebuild the graph. So this is our updated data model, and when we go into the data editor view, we can also see our change being represented in this view, because now we have a enum instead of a string. So now that we have added mass unit and temperature unit, what we can also do is to introduce more advanced constraints. So for example, what we can do is so let's open this GUI editor view, which will show us all the options that JSON schema, the language to define the data model, has. And let's navigate to the time. What we will see is we can also define a title, a description, and more, a maximum value, a minimum value, and even advanced options such as combining different conditions and so on and so on. So now what we want to do is we define that the minimum time value is 0. And that's it. So now we have defined this constraint also. And let's close the window again. And so now going back to our original use case, what we wanted to do is we want to have a unified data model that we can share with all people included in our project, even of different countries, with anyone. And they can now arrange their data in this same structured manner so that we can develop and use the same kind of tools on it. So just let's take one quick look into the data model again. So this would be the data model file. Now we can also see a minimum of 0 for the time. And this data model will result in this view. And let's say we would enter a negative time. Now also we would get a complaint that the time must be at least 0, because all of these constraints, they are reflected in this view also. Right, so now we have Python code that we want to use to enrich our JSON document, to add new metadata to the document. It is copied and adapted from the code from Thorsten from the biochemistry department, and it uses the PubChem database where we can query for a compound by giving a smiles code or inchy code or some other ID, and it will return the pubchem compound. In our document, all the linkers and metal salts are compounds. So for them, we want to get the pubchem compound instance. And then we can call this function, collect metadata for the compounds, which will give us the inchy code, smiles code, UPAC name, and molecular weight for the compound. So what this code does is, for every compound, it will loop over it and get the metal salt and what metal salt name, and collect the metadata of the metal salt name by using the two functions that I just showed. And in the same manner, it collects metadata for the linkers. And then it will append to our JSON document for our entry a metal salt property and a linker property, both of them being the metadata. It might sound a little complicated. Let's just run the code. Finished? Okay. Then let's look into the JSON, and what we will see is the structure until this point looks the same, but now also it has a new metal salt property being the metadata of the metal salt, and a linker property being this information. The metal salt metadata was created by using the metal salt name. So we look up this name in pubchem, and then we retrieve the corresponding metadata. So this we have done for all entries. So now, because we had our data in the JSON format in a very standardized way, we were able to write this Python script to enrich the data. Now also, because our data model changed, because we added new data, let's reflect this change in MetaConfigurator by editing the data model. So what we want to do is introduce a new compound type. And this type, so we call it compound, and it will have a property that it has a CID, which is a number, a inchy code, which is a string, and so on. So we have a CID number, inchy code, string. Now what we could do is, if we go to our inchy code, would be to add some new constraint. So if we switch to this graphical view and we select the inchy code, we could define a pattern, which would be, so I'm pretty sure there exists some regular expression which describes the pattern of an inchy code. Now we could enter it right here, and then users could only enter valid inchy codes if they follow the data model. But for now, let's leave it out. And yeah, let's add also one more property of them. Smiles code also is a string, and now this type applies for our new metal salt attribute property and also for our new linker property. For the sake of time, I am not adding every single attribute of them. Metal salt is a compound, and also linker is a compound. And now going back into this view, we will see for every item we will find this sub item which would be having these properties. Now that we have enriched the data, let's add them to one sample item also in this dataset. And we will see that the structure matches our data model. So going back to the data model, yeah, what we now did is we imported our Excel file, which was in a non-standardized way, and we converted it into a JSON document. We defined a standardized data model which we can share with anyone, and we now have our data in this data format. And because it follows this standard, we were able to use tooling which enhances, enriches the data. Any other kind of tooling, such as machine learning and anything else, could also be applied, because our data now is in a standardized machine readable way. And if we share our data model with other researchers and they also fill in the data in the same manner, now we have data that is compatible, which is a big benefit.